everybody, I'm excited today to talk to you about supply and demand, two topics from economics. Well, really, they go hand in hand, so it's really like one topic. So, two of the most basic principles in economics are the law of demand and the law of supply. And both of them are phrased here in terms of the price. So, the higher the price of a commodity, the lower the demand. That's the law of demand. On the other hand, the law of supply tells us the higher the price, the more items the seller will supply. So as the price goes up, the supply goes up. I imagine for a lot of people these seem very natural, but I actually had a hard time with these laws when I first learned them, in part because I kept picturing food at a grocery store. Maybe I was just hungry that day. And then meanwhile, the examples given in textbooks are usually more like agriculture. And that I also had a hard time with because I was thinking if you're a grower and you have thousands of tomatoes, are you going to withhold your tomatoes from the market based on the price, or are you just going to go ahead and try to sell your tomatoes? So I struggled with this because I kept trying to attach too much of my own life experience to these laws without really understanding more when they would actually apply. So now, whenever I think about the law of demand and supply, for me, it feels most natural if I think about something like the real estate market, say here in the Raleigh area. So the law of demand says the higher the housing prices are, the lower the demand. Right? If houses in the triangle are too expensive, people are not going to buy them. They're going to rent instead. And then the law of supply would say the higher the housing prices, the more houses are going to hit the market. Right? So if you found out that your neighbor sold their house way over what you would have expected, you might be more inclined to try to sell your own house. So it's like higher prices drive buyers out of the system, but also incentivize sellers. Okay, so we're going to think of supply and demand as quantities. They're going to be numbers, like the number of houses on the market and the number of buyers buying houses. That's an amount, which they both vary with respect to price. When the price goes up, demand goes down, supply goes up. So they behave oppositely. Okay, what we're going to first do is model supply and demand for a commodity. And we're going to give a very simple model for each. So in particular, we're going to assume that the rate of change of each is constant. In other words, you would see the same amount of change in the demand if you increase from $10 to $11 as if you increased from $60 to $61. In other words, if you were to plot demand versus price and supply versus price, they would be straight lines. They would have a constant slope. For an actual commodity, they don't have to be, but that's going to be the assumption that we make today. Okay, so those slopes, the rate of change of one quantity with respect to the price, those are parameters. And then also let's attach some meaning to the intercepts of the lines that we're going to create. Those are also going to be parameters, the intercept values. All right, so I've given you here 4 parameters. 2 are for slope and 2 are for intercepts. So let's think through each one. Let B for buyers be the highest possible demand. Say if the item is free. If the price is 0, how many people actually want this commodity? So that's going to be an intercept. The price being 0 is the quantity axis for demand, so that's going to be an intercept on the quantity axis. Let negative A be the rate of change of demand with respect to price. It's negative because as the price increases, the demand goes down. We're setting it up as negative A because A is going to be positive. So that's going to be a slope. Okay, then I'm calling it U here, although we'll eventually get rid of that parameter. We'll replace it with something else. But U is for unacceptable. That's the unacceptable price at which the seller refuses to sell. So anything higher than that, and you'll get items on the market, at U or below, you won't have any items on the market because the price is just not acceptable to the sellers. Okay, so that means that the quantity is 0 at that price. So that's going to be an intercept on the price axis. Let V be the rate of change of supply with respect to price. So that's another slope. So the first 2 parameters are for demand, and the second 2 are for supply. Keep in mind as we go forwards that all parameters are positive. So if you see the product of two, that's a positive number, or the ratio of two would be a positive number. We can put them now together to create our functions representing demand and supply. These are going to be quantities that depend on price. So for demand, we have d of p equals, and then in slope-intercept form, it's going to be negative a times p plus b. That was straightforward because we had the slope and we had the intercept on the quantity axis. In other words, the intercept on the y-axis, the dependent axis, so that would be like the d-axis. On the other hand, we have to be careful how we use the intercept given for the supply function, and that's because it's the x-intercept really if you're thinking about price as the independent variable. I want to be careful there when I say it's the intercept on the x-axis because as you'll see in a minute, we're actually going to flip the way the axes are used when we graph these, but just writing them now as functions, thinking of supply as the dependent variable and price as the independent variable, we can say that s as a function of price is going to be the slope times x minus the x-intercept. So that's going to be v times p minus u. Now if I distribute, we'll have Vp minus Vu. If you look at these equations, I have V twice. I only have U once. We're never going to use U by itself. So actually, let's just roll these into one and call that W. So that we still have four parameters, but our line equations look a little bit more simple than they would have otherwise. So we'll write that the supply is Vp minus W. Okay, these are straight lines, so we're going to plot them, but we're going to make it a little bit harder than it has to be. But it's not my fault, it's economics' fault. Normally, y goes on the y-axis and x goes on the x-axis, right? That's like a fact about graphing. But in economics, they usually plot quantity on the horizontal axis and price, what we were thinking of as the independent variable when we wrote down those equations, that goes on the vertical axis. This is convention, so this is what we're going to do today. But if you're struggling to read these graphs, keep that in mind because it might explain where you might be going wrong. So if you're like, why is it doing that? Keep in mind here that we've flipped the roles of the independent and dependent axis. But even ignoring the way the axes are labeled, looking at this, the shape shouldn't surprise you. Demand is going down, supply is going up. These behave differently. As the price goes up, demand goes down, but you have to be careful how you read this kind of graph. So as the price goes up, demand goes down means we travel from bottom right to top left. So going in this direction from the bottom right to the top left is our notion of a decreasing function of price. So a higher price means a lower quantity of demand. So we go this direction as price increases. And then what is this point right here? That's a certain amount of quantity. That's how much would be demanded. That's how many buyers are looking for a house at that price. Okay, so just be careful when you're looking at a point, what you're thinking of as the price and the quantity relative to the axes. Since these lines are not parallel, they're going to intersect exactly once. This point is called the equilibrium solution or the steady state. We'll denote it as P star. Even though it's got a price component and a quantity component, basically it's the price where supply and demand agree. So the suppliers are willing to meet exactly the demand at this price. Everybody is happy. So at P star, we have that the demand at P star equals the supply at P star. Now, if we plug in the equations that we came up with, we're going to find what P star has to be in terms of the four parameters. On the left-hand side for demand, we have negative A times the equilibrium price plus B is going to be equal to, on the right for supply, it's going to be V times the equilibrium price plus W. Now we just solve. So we have, how about negative a minus v p star equals w minus b. Oh no, that's not right because it should have been negative w up here. So that's going to be negative w minus b. Let me just fix that. Everything's negative. I could go through multiply both by -1, solve for p star, and we get p star equals, let me write it in alphabetical order as b plus w divided by a plus v. Okay, so that's the price here in terms of the parameters. And then to figure out the corresponding quantity, you could just plug that price into either function. So at this price, just based on the graph, we would be looking at supplying about 2.7 thousand units and also demanding the same amount. So the market's reached some steady state condition. What if we're not at that steady state? Let's suppose that our commodity hits the market and it's at price level 7. So I don't know if that's $7 or $7,000 per unit or something like that. But let's say that we're here on the price axis. We read out horizontally. So at this price, how does the supply compare to the demand? So at that price, suppliers are willing to sell a lot of units, but the demand is low because buyers think it's too expensive. So there's more supply out there than there are buyers. That results in a surplus. So we can say if the demand at some price is less than the supply, what we get is a surplus. When the market is flooded and people aren't buying it, the only way that that can be fixed is if the price drops. So I don't want to put too much on this graph, but what we'll do is we'll say that the price is going to drop so that the demand is meeting the current supply. So we can imagine that as coming down here. Let's say 7 was our initial price. Now we're at some new price, just over 4. We'll say this is the next price in our sequence of prices. Okay, so now we have a new price P1, and we want to compare the demand and the supply at this new price level. So what we do is we say, okay, well, what would be the supply? Let's just travel to the left. Here's how much suppliers would provide at that price. The demand is much greater than the supply. Everyone thinks it's a good deal. Buyers want to buy it. Sellers think they're not getting enough. So at P1, D of P is greater than S of P. Whenever the demand is greater than the supply, it means a shortage. Because the demand for the product is greater than the supply, it's becoming rare. The market will correct and prices will go up. So from here, the price would go up to this new level. You can call that P2. And then the process repeats itself. So at the price level P2, once again, we have a surplus because when we compare the demand curve to the supply curve, demand is not meeting the supply, so the price needs to drop. We would drop down here, etc. Let me go to a new graph where we're just looking at the spiraling behavior. This is called a cobweb diagram. So if we start here, the seller either likes the price or doesn't like the price. Whenever the seller likes the price, they have a large inventory. Whenever they don't like the price, they have a low inventory. That's just going to follow the supply curve. Then there will be a sequence of market adjustments to alter the price so that the demand meets the current supply. So if we start here, There's a surplus. So there's a market adjustment. So you can always think of these vertical lines as market adjustments. To the right of the equilibrium crossing point, it's going from more expensive to less expensive. On the left, it'll go from less expensive to more expensive. But now we're at this price level. The seller does not like the price, so they lower their supply. So at this price, the seller is only willing to offer this many units of the commodity. Now we're in a shortage, demand is high, the market makes an adjustment. Again, this time from cheaper to more expensive. Now the seller likes the price. This is a good price. So the seller says, okay, let's offer this much supply on this market. We would like to sell all of that. However, now there's a surplus, there's another market adjustment. The seller doesn't like the price. They offer fewer pieces of inventory. There's another adjustment, but you can see it's getting less and less dramatic because we're spiraling in on that equilibrium solution. So whenever you're looking at these cobweb diagrams or you're trying to make one, if you've graphed them this way, where you have quantity on the horizontal axis and price on the vertical axis, you're going to follow the adjustments in a clockwise fashion. Okay, so this is how our market works. We've got our supply line worked out in terms of the parameters. We've got the demand curve worked out in terms of the parameters. What we would like to do now is better understand the price levels. So can we come up with an explicit way to compute what, say, the fourth price is going to be after adjustments? So now that we've modeled the market adjustments, let's determine the price of the commodity over time. We are going to create the equation for the price. And what we're going to do is just translate the behavior that we saw on that cobweb diagram into an equation. So the idea is every time the market makes a correction, every time we traveled vertically in our cobweb diagram, the price changed so that the demand would meet the supply. So when there was a surplus, we lowered the price to increase the demand to the supply level. When there was a shortage, we raised the price because we said there's more demand out there. Let's make money off of it. We're going to end up modeling this with a difference equation, generating a sequence of discrete prices rather than a continuous change because we're imagining that these corrections happen maybe every day, once a day, or once a week, or something like that. So we're thinking of this market as correcting itself at discrete moments. So we'll start with some initial price, P0, and then we'll make an adjustment to P1. Based on the dynamics at P1, we'll make an adjustment to P2. So given this idea that we're changing the price so that the new demand matches the supply, we'll derive the difference equation for the price using the idea that the new demand, so demand at what we'll think of as Pn plus 1, equals the supply at Pn. So the new demand meets the old supply. So this was our principle. The idea is that the changing price is going to push the demand to the current supply. Now on the left and right hand sides, we just plug in our formulas for D and S, where on the left, we plug the price Pn plus 1 into D, and on the right, we plug in Pn. For some reason, I switched the order of terms here compared to how I was writing it before, but those are the same lines. So now we can solve for the new price, Pn plus 1, in terms of the old price. So we get the new price is negative V over A times the old price plus B plus W divided by A. So it could be higher, it could be lower. The price and all these parameters, those are positive numbers, but the question is which of these two terms is larger? It's either going to be a little bit bigger than the previous price or a little bit less than the previous price, depending on the direction of the correction. Okay, this is a nice form of a difference equation. So we have constant coefficients, and we have a prescribed way of solving this. So what we're going to write down is a closed form function p of t, with the idea that if we plug in discrete moments like t equals 0, t equals 1, t equals 2, we're going to generate our sequence of prices. So using the form of the equation for this type of difference equation, we can say that this is going to be p of t equals the initial price, whatever that was, times the coefficient of the pn term on the right, so that's negative v over a raised to the t power, plus that constant term on the right, so b plus w divided by a, and then times 1 minus negative v over a raised to the t power, all over 1 minus v over a. We're going to be able to do a lot of simplification here. In particular, let me multiply these denominators together and I'll put them over in the fraction on the left. So this will simplify to the initial price times negative v divided by a raised to the t power plus the same numerator as before, b plus w. And actually, I have a mistake here. It should have been 1 minus negative v divided by a, so that should be 1 plus. Okay, so it's going to be a plus a times v over a, or overall a plus v. And then the numerator, let me kind of write that off on its own to the right. So that's 1 minus negative v over a, all to the tth power. And this you might recognize as that equilibrium price that we were calling p star. So let me plug that in. And we're going to say it's the initial price times negative v over a to the t plus the equilibrium price times 1 minus negative v over a to the t. The initial price is a number, the equilibrium price is a number, then we have parameters here and our independent quantity time. So what can we do with this closed form expression? Well, for one thing, you can plug in t equals 0 and you get back the initial price. Then if you plug in t equals 1 and you know your initial price, you'll get the first market correction P1. So if we go back to our Cobweb diagram, this price over here would be P0, and then you plug in 1 and you would get this price. You plug in 2 and you would get that price. So it's going to generate the sequence of prices. But it's also going to tell us the long-term behavior for those prices. So the question is, where is this market heading? Are the prices approaching the equilibrium solution? Are they fluctuating wildly? That sort of thing. So the key idea with this equation is that if the absolute value of, let's call it little b, is less than 1, then b to the t goes to 0 as t goes to infinity. So if this fraction v over a here is less than 1, then as time goes to infinity, or as time gets larger and larger, this would go to 0. So eventually, we would not even really see the influence of the initial price, and this first term would get arbitrarily small. On the other hand, if we look at the ratio over here, if this goes to 0, then this quantity goes to 1 because it's 1 minus approximately 0, which means that the long-term behavior would go to P star. Instead of writing if V over A is less than 1, let's just think of that as a comparison between V and A. So in particular, if V is less than A, both are positive, so we don't have to worry about negative numbers here. If V is less than A, then V over A is less than 1. So the long-term behavior of the price is towards the equilibrium value. That's the behavior that we already observed with our Cobweb diagram. So we only have a few market adjustments here, but we see ourselves spiraling inwards. It's like we're getting trapped closer and closer to P star. That's exactly what the condition we just wrote down predicts. It's very unlikely that these would be exactly the same, but what if V is A, so that this ratio negative V over A is actually -1? So we can say, well, what happens if that were the case? So if V equaled A, then negative V over A is -1. So P of T is going to be one of two values. We can write this as like a piecewise condition. If T is even, like T is 0, 2, 4, then negative V over A to T would be just 1. And we would have that the price would be P naught plus the equilibrium value times 1 minus 1. So it's actually just going to be P naught. If T is odd, then -1 to the T would be -1. So we would get negative the initial price plus, and then 1 minus -1 is 2, so it would actually be plus 2 times the equilibrium price. So there's no long-term behavior. We would just bounce back and forth between two values. That's not something that you're actually likely to observe. Mathematically, it's more likely that you're either looking at V less than A or V greater than A. So what happens if V is larger than A? If V is larger than A, then let's say it's 2, just for illustrative purposes, -2 to the T is going to grow arbitrarily large in terms of its magnitude, and it's going to alternate in signs. What you would observe is that the corrections would get larger and larger, and basically your market would be fluctuating outward away from the steady state. What would that look like? It would look like this. So what happens is if we start at the same place as before, that's actually down here, because we're going to read clockwise, the price adjusts itself again because we're in a surplus situation. The seller doesn't like the price, so they lower their supply. But now there's a shortage in the market, driving the price up. However, it's now being driven up to higher than where we started. The seller's like, that's great, I want to sell all my quantity, but now there's not as much demand. So it's the same principles as before, but what's happening now is that we're spiraling outwards rather than inwards away from the equilibrium price. I don't think you actually observe this in actual marketplaces too often because it's going to have to correct itself at some point. But mathematically, this just leads to larger and larger swings away from the equilibrium price. With our price function, we can now plot P as a function of time. So let's take a look at that. So just take a second here to compare what you're seeing here, which is price over time, with the three conditions that we just named. So which is which? So in each picture, the equilibrium price is plotted as a dotted horizontal red line, and the price curve is going up and down. On the left, what we see is that the price is essentially oscillating kind of out of control. So this would be the case that V is greater than A, so that we get divergence. And we would call this an unstable market. The middle one is that special situation where V equals A. Probably very fragile, hard to get exactly that, but that would just be oscillation between those two values. You can see P naught down here and 2P star minus P naught up here. So those are the two prices that the market would correct between. Each is equidistant from P star, right? So we just go from underpriced to overpriced, underpriced to overpriced. The condition on the right is the most common condition if you were actually modeling a commodity. This would be V less than A. And what we have here is that we start at some initial price. Apparently it was cheap, so then it goes up. This would be P1 after the first market correction, then down to P2, then up to P3. But every time the market corrects, it gets a little closer to that equilibrium value P star. So we say that this is converging to the steady state. And this situation where asymptotically as time goes by, our sequence of prices is getting closer and closer to P star, we call this stable or asymptotically stable. At this point, what we've done is taken parameters that describe the market we're looking at. So we have some ideas about how our buyers and sellers are operating, how they react to price. We used those parameters to write down two equations for demand and supply as a function of price. We then reasoned out what the market should do, how the price should adjust itself in terms of supply and demand. And then ultimately, that allowed us to put together a discrete difference equation for the sequence of adjustments for those new prices. And then with that difference equation, we could come up with an explicit closed form formula for price. So you can just plug in t equals 50 and compute the price if you want. I want to do one thing before we finish today, and that's take this equation that we're looking at right here, P sub n plus 1 equals negative V over A Pn plus B plus W over A, and I want to give it a little bit more meaning so that you could almost write down this equation from scratch without starting with the demand and the supply. It'd be a little bit tricky, but again, I want to take this equation and essentially rearrange terms so that we could translate it back into reasonable words. Okay, so this is just going to be algebra. What I'm going to do is keep my left-hand side as it is. I won't change that at all. And I want to say that the new price is going to be the old price plus or minus something. So if you're the market, you would say, hey, let's take that previous price, P sub n, and adjust it. So I would like to have a form that's Pn plus 1 equals Pn plus something or minus something, depending on the sign. To do that, I'm going to add and subtract the same quantity to the right-hand side that will force this left term, negative V over A times Pn, to be able to be simplified to just 1 times Pn. So to do that, let's add on the left 1 plus V over A times Pn, and then we'll do minus V over A Pn, and then plus B plus W all over A. And then I added a term on the left that didn't exist before, so we have to cancel it out with itself. So we can do minus the quantity 1 plus V over A times P sub n. Okay, so that way nothing has actually changed because those two terms were the same. Okay, but the terms were written in such a way that I can take these first two and say, actually, that simplifies to just plain old Pn. So on the right-hand side of our equation, we have P sub n plus, and then on the right, I could just write everything out as it is. Notice I have those denominators of A in common with two of the three terms. Let me pull out 1 over A, and then I'll be left with B plus W minus A, because 1 divided by 1 over A is A, minus, actually A times P sub n minus V times P sub n. And then if you compare these expressions to our demand and supply functions, B minus A Pn is what we would call D at Pn. And on the other hand, W minus Vpn, if you combine those together, that's actually negative S at P sub n. So I could write this as the previous price, P sub n, plus 1 over A times the demand at P sub n minus the supply at P sub n. So we can now take that right-hand side and say that's the previous price plus some market adjustment. And moreover, we can see what the market adjustment would look like based on how we could have a shortage or a surplus. If it's the case that the demand at the previous price was greater than the supply at the previous price, then we have a shortage. So we would have the previous price plus an adjustment reflecting the shortage. So the new price would be larger than the previous price. On the other hand, if the demand was less than the supply, then we would have a surplus. So D minus S would be negative. So our new price would be the previous price plus some scaled amount reflecting the size of that surplus. So the new price would go down. And then lastly, if the demand was equal to the supply, if those two quantities were the same, there would be no adjustment whatsoever, and you would have the new price is the same as the old price. Okay, I'll end with this form because I think it's a nice interpretation of the difference equation for price. I hope you enjoyed taking this quick look at the laws of supply and demand with me. Thank you for your attention.